Okay, so we'll take a look at constructing and analyzing some graphs, more the construction in this particular video. The first thing we want to take a look at are the two types of variables. So there's two types: categorical data, which you can see right here. You're going to place things into categories, right? So we'll kind of highlight that. So categorical, right? Pretty obvious. You're going to put things into categories. The next type of data is what's, or there's a couple examples, excuse me: eye color, favorite food, and then the next type of data would be quantitative, and that's where things take on quantities, not necessarily the number one way to tell, and you'll see that in a minute. Right? Do things take on numeric values? So some examples there: height, weight, income. And within quantitative, there's two different types of quantitative variables. You have discrete, where there's a certain number of values. A really good example here would be like the number of goals in a soccer game. You can score 1, 2, 3 goals. And then you also have continuous, where there's an infinite number of values. So maybe like heights of males. You could have someone that's 6 feet, 6'1", 6'1.5", 6'1 3/4". So you can get a lot more into the fractional values if you want to kind of think about it that way. So something continuous like that would maybe a good way to think about it. Can you start to throw like some halves in there? A couple of examples. So what kind of variable you look at with gender? Gender is an example of a category, right? You're into one or two. Telephone area code. Although there are numbers involved, your area code actually places you into a category. Like the 919 area code is the Raleigh, Durham, Chapel Hill area. Amount of electricity used. So this would be a quantitative, and if you think about it, right, you can use 16 kilowatt hours, you can use 16 and a half, you can use 16.4. So not only is it quantitative, it's also a continuous quantitative. Zip code, and again, although there's numbers, we think about it this way: it's still categorical because your zip code places you in a certain, or where you live is part of your zip code. Ticket sales at a Miley Cyrus concert. Now here's one that takes on a numeric value, and it's a certain set number. There's a finite number, right? They could sell 100 tickets, 101 tickets, but you can't sell 101.2 tickets. So here's a quantitative that's discrete. Number of chicken eggs that hatch at this particular day, at this particular time. Again, this is a quantitative value, and it's discrete, excuse me, because again, you can have 12, 13, 14, but you can't have 13.6 eggs that hatch that day. So a good filter for quantitative in terms of continuous versus discrete would be, let's start thinking about fractions or decimals. In terms of sometimes determining where to go with categorical versus quantitative, especially if you start thinking about something like zip code or area code where there are numbers involved, sometimes it's a little bit confusing. But what we can do there, the big thing to think about: does it make sense to take an average? So it doesn't make sense to take the average zip code in a class, but it does make sense to find the average ticket sales for Miley Cyrus's concerts. So when we start thinking about types of graphs for different types of data, so for categorical data, you got this type of graph, which we recognize pretty quickly as a bar chart. And one thing to be aware of with that bar chart is the bars never touch. Also a great graph for categorical data, if you have the situation where you have parts to a whole, where you can break things down into percentages, that's where a pie chart can come in very handy. You think back just a moment, this graph doesn't break down well in terms of percentages, but you do have these different categories, so a bar chart is appropriate. All of a sudden, you think about out of the class, you know, 98% of the students are going to try to take the personal challenge versus the 2%, which are going to adhere to the warning and start early, right? So that encompasses each part of an entire class. Before moving forward, think about this for just a minute. Sometimes graphs can be misleading, and if you look closely here, it looks like the number of deaths has plummeted, or the number of U.S. deaths in Iraq, so I'm assuming our soldiers. But if you'll notice, right, this is in March of 2006, so we're missing a big chunk of the year. So the thing that's kind of scary about a graph like this is all of a sudden this was published, this was thrown out there for people to see and to read and to make draw conclusions about, and it's very, very misleading in the fact that there's a big chunk of the year missing. We look at this one in class. Sometimes people can take two things that have nothing to do with each other and make graphs that make it look like there is an association. Later in the class we'll get a lot more into this, but This is something that'll happen quite a bit out there. Just people are able to make these connections, and if we're not good consumers of data, all of a sudden we think there's a connection between two things like global temperature and piracy, and really it has nothing to do with each other. So back to our types of graphs. Now we can go quantitative variables. Two that we're going to look at really quickly. There's dot plots, which are useful for smaller sets of data, as well as stem and leaf plots. But a lot of times what you get with a stem and leaf plot, you're going to actually see the individual pieces of data, so you get a little bit more information. So quick example of a dot plot. So let's say that we went through the class and we got number of siblings. So we'll go ahead and create our axis here with number of siblings. Oh, my S in there. And there's a 0, 1, 2, 3, 4. And then basically it's a dot um, or an X. I'm a big fan of the X, so we've got a 2, you got a 4, you got another 2, there's a 1, a 0, a 3, a 2, another 3, another 0, and then 2 1s. So we'll title this, excuse me, I almost said table. We'll call it number of siblings, right? And so there's some stuff that we can start to see with this particular graph. I don't know why that in this particular group of students or people that most people had 1 or 2 siblings, right? We can see that there's a few only children, and we can see that nobody in this group had more than 4, right? There's a few different things we can pull out of this. One thing to be aware of, if you look, I tried to make all of my x's about the same height so it's not misleading, so we can kind of see the taller bar or the taller stack goes with the mode, if you will. So another thing to keep in mind here, as you're making these graphs, you want to make sure that you have a title, that you label your axes, and that you have units that are identified. All right, so let's look at some data for a stem and leaf plot. So a lot of times, again, as we create this, we can sort the data. And if the leaves become too large, then go ahead and split them. So this is probably a big one to really think about. Oh, excuse me. This is probably a really big one to think about, especially in this data that we're about to see now. The big thing here, a stem and leaf plot's not going to have an axis, so what we want to make sure to do is to create that legend, and we'll make sure everybody's good on that. So here's some data on heights of some students. So to create that stem and leaf plot, you see we're in the 60s and 70s, but there's quite a few 60s, quite a few 70s, so this is where we can split the stems, and we can have 2 stems for the 60s and 2 stems for the 70s. So the first half of the 60s. So we start kind of looking through this. There's a 61. There's a 63. There's a 65. So now we're into the second stem there. 65, 65, 66, 67, 2 68s it looks like, and a 69. And then we go into the 70s. There's a 70, a 72, a 73, a 74, and a 77. So again, you can kind of see that I'm trying to keep the numbers about the same size. And you see that typically most people are in the high 60s in this particular class. Now, we need a title, right? So we'll call it number of siblings, or excuse me, I'm in the wrong mindset here. This will be heights. I'm thinking about the last one that we just did. So this will be heights. And instead of having that axis, we need to go ahead and do that key. So we'll do 70 means 70 inches. And right away, we also get the units.